Hello. Yes. Hello, good morning, good afternoon, good evening, depending on where you're connecting from. My name is I am Okiru Kaubilo, a cloud engineer, and I'm the cloud instructor for the ETSAP program. So this is our first recorded class for the cloud computing class. Yes, we will be taking this cloud journey together. I hope it will be fun and impactful. Because of the diverse nature of the students that we have on this program, because I realized that I was told that we have the techies and the people that are coming from non-technical background. I'm going to try as much as possible to make this course easy to understand, and I'll use pictures and stories to make it as easy to understand as possible so that even a layman can, grab what we're saying or grab what I'm explaining about the cloud. So this is the first level, the level basic of this cloud course. There will be intermediate and advanced. So for the basic, we'll make it as basic as possible. And thus, why you see why I wrote Cloud Essentials. Okay, so let's dive in and get to it. Cloud computing. What is cloud computing? Let's get on with a definition here. So cloud, just 1 second, please. Okay. So when we hear about the cloud, what's the first thought that comes to mind? When I was starting out in tech, my background wasn't even tech. So that's why when I try to teach out, I try and make it as easy as possible for anyone, even those coming from a different background, will be able to understand. So what is tech? What is cloud? So like I said, when I was starting out, I used to think cloud was, when you look up those things up there, the white clouds that you see. So that was what I assumed you were talking about. It didn't make sense to me. So I kept wondering, what does tech have to do with, the clouds up in the sky? And I thought that for a while, even when I already started out in tech. Okay, and I know some of us might actually think that too when we talk about cloud. Okay, but because even when you see that when there is a cloud courses, most of them use the cloud icon. okay, making it even more confusing. Okay, so but cloud is just a building filled with computers. The cloud is a building, a massive building filled with computers, filled with what we call servers. So a server is actually a big computer, a mega computer. Is a computer, when I say computer, it could be your laptop. Your laptop could actually be a server. The desktop could be a server. But now we're talking of servers that have massive storage spaces, computing ability. I'll be showing us a few in a minute. So a server is, I'm trying to mute my notification so that it doesn't distract us. Just 1 second, please. Okay, so is simply a server is simply or cloud is simply a big building filled with computers, and a server is a computer that has massive compute, massive ability of compute. Like it's your laptop might have maybe 8 gig, 16 gig, but a server is, we're talking terabytes here. We're talking like massive, massive, you know, ability to compute, to also store. Sometimes when you're storing things on your phone and even on your laptop, it will tell you storage is full. But with a server, it's so big that it takes a while if you're using, because there's different types of servers anyways. But yeah, so servers are very big compute, has ability to do a whole lot of things, a whole lot of things. So a cloud is a building like what you're showing, I'm showing in this picture right here. A cloud is just, the cloud is just a big building somewhere in where you might not even know. Okay, let's use instances. Maybe that will help us understand it better. So a cloud could be in US, it could be in Europe, the cloud could be in this building that I'm showing now, it could be in different places, and it's in different places around the world. And what are they? They are just simple buildings, massive buildings filled with mega computers, filled with massive storage servers. Okay, like I said, big computers are called servers. Okay, so they are basically called data centers. So data centers is a physical facility that houses computer systems, networking equipment, data storage devices, serving as the central hub for an organization's IT operations. It's designed to provide, a controlled environment for these critical components, ensuring their reliable and secure operations. Okay, so that's the definition right here, but let me break that down. So like I was saying in the initial slide, the cloud is a building. So these buildings are called data centers. And data centers are buildings filled with computers. They are house computer systems. Okay, but then the servers have to also have what we call network equipment. That's why you are able to connect to the servers. Then we have the data storage devices as well, where and all these are all interconnected. Like I said, I'm going to show a picture shortly. They are all interconnected with cables and wires for us to be able to access them through the internet. So it could be a central hub for an organization, organizations' IT operations. It could also be for sale to organizations. Okay, so it's designed to provide a controlled environment. So inside the data centers, I happen to have worked in a few of them. So it's very cold, very cold. Why? Because of the level of computing going on those machines, they tend to get very hot. So the data center is not really a place where those machines are. It's not really a place where you just go in and sit down there and have no. You probably freeze because it's very cold. It's not like a cold room, no, but they put. That's why you have that controlled. You have this controlled environment here. It's controlled to maintain a particular temperature so that those machines are being cooled even as they are working. Let me quickly show us a picture here of what I'm talking about. 1 second, because that will help us get what I'm trying to explain. Like I said, I'll try and make it as easy as possible for us to understand. Okay, so I just went to Google and I typed data centers. And this is what I'm trying to explain here. So these you see here are servers. So you can imagine, look at this right here. This you are seeing all lined up here. These are servers, and they are racked. They are racked. You see. So in this rack now, you are going to have storage devices, networking devices like switches and routers, but that's not our focus right now. Our focus is to explain the general concept, which is cloud computing, which actually takes place within a data center. So here you probably have like the places I worked in. We usually have the router, the switch up here, the router, the switch, and then the rest here will be the servers, and then down here we'll now have the storage devices. But each data center has its own setup. Okay, so this is the front end of the data center. Let me expand the picture a little bit. Okay, so yeah, so what you're looking at here, so you see this environment is cold. Like I said, not as cold as a cold room, but still cold. So this is a data center. This is what the inside of it looks like, and this is like the front facing part of it. Let me show the back, because now you're not seeing any wires here, but at the back, that's why you now see all the wires. Most times they are color coded. Okay, so this one is not really showing it so well. Let me see. Yeah, this showing it a bit better. So this is the back. That room we just saw, this is the back of it. So you see the wires, the cables are color coded. We are seeing the blue, the yellow, and then the orange. Okay, so this is color coded, one, to help the engineers that work in here to know what is connecting to what, to know the ones that are servers, to know the ones that are the storage devices, the switches. So these are the wires. This is the back end of the data center. So you see the green, the blue, the orange. So each data center, because I wouldn't want to use the one I worked in as an example. I don't know, each data center has its own color coding that helps the staff to be able to figure out what is connected to what. Okay, so yeah, so when you hear cloud, this is actually what it is. It's just a massive building somewhere in the world that houses rows and rows. You see the rows and rows and rows of servers, storage devices, networking devices, all brought together to provide service, compute, for an organization or for sale. Okay, so at least that will give us an idea now. We better understand. So when someone says cloud, you now know that it's not those things up there that's white or blue in color. It's a data center somewhere. Let me also show us maybe, let's say, okay, Google data center. Let's do Microsoft data center. Let's see what it shows. So you see, in fact, the data Microsoft has their data center. Some of the data centers are housed underwater. That is the level of innovation that we are in right now. This one right now is, if you read this, underwater data center. It's a data center that is underwater. Why? Because they need that environment to be cold. It needs to be, chilly. So instead of providing for ACs and cooling devices like the ones that are on ground, they put theirs underwater, because of course we know underwater is cool, So that's the level of innovation. The data center can actually be underwater. I think Microsoft was one of the first ones that were able to achieve this. Okay, so see another one, underwater data centers. So it comes in form of like a cylinder buried underground, but inside it, you're going to see these things I just showed you now. This, servers, storage devices, networking devices, the same thing, just that it's now in a cylinder form placed underwater. But in the regular, the ones that are on ground, if you look at this, if you look at this picture here, you see the massive, rows of buildings. See another one here. I just wanted to show us the external part. See another one here. See this one here. See this one here. So it's so big that you actually get there, you get lost. I know. I remember. I got lost in some of the ones I worked in. If I actually use a GPS to track your way around the place. Okay, so yeah, so that's that. So I think we get the picture now. So when you say cloud, that's what it is all about. So why is it called cloud? Remember, because we connect to it, through the internet. So you can connect to any of these servers anywhere in the world through the internet. So that's that. Now let's continue. Let me quickly share the slide again. Okay. Okay. So cloud computing refers to data and applications being stored and run on the cloud rather than on your local computer. So before now, if you wanted to um, run, uh, let's say you have an app you want to develop, everything was done using our computer. Even the emails, you had to go buy an email server, set it up, connect it to be able to send email. We wanted to build an app, you're going to go and buy a server, and servers are not cheap, not at all. You buy a server, you buy a switch, and all of that to be able to build the app. Okay, so before now, everything was done locally within your space. Even till now, a lot of organizations, especially here in Africa, because of the high cost of cloud, providers, cloud service providers, some organizations still use this local method. Why do I say that? If you remember, or if you observe, or even if you haven't observed, now that you are into cloud, you're going to observe that when you go to some organization, let's say the bank, the general one that most of us normally go to, there's a room called the server room. Most organizations have that. There's a room called the server room. So why is it called the server room? That's actually where their servers are. So these people that you see, those tellers that you see at the front end, all they have is maybe a laptop or a desktop, but they are connecting to something within that building where they can access your account details. Can That's why you can is this teller here, teller one can serve you, and next thing is telling you, oh, the system is down. They will tell you go to teller three, and you get to teller three, your information is still with teller three. So, or they tell you to go to customer service. So you get there and your information, they just put your name, pam pam, and your information comes out. How is that happening? It's because that information is stored somewhere, maybe within the building or outside the building. But like we're saying, for the ones that are locally hosted, there's the information is within that building, and because it's within that building, they can access anybody within that building that's connected to the server. You see the hidden wires running along the ground. Usually they use the white ceiling thing to cover it. Some of them run on the walls, or inside the ceiling that goes into the server room. And those that have been able to, have access to the server room, mostly nobody even has access there apart from the IT people, which you are becoming one of them, because now you are learning cloud computing. So inside that server room is very cold because they need to keep the. In fact, if the AC goes off, sometimes the machines get overheated and sometimes they blow. We had an experience where I was working, the server room got burnt. It got overheated because there are a lot of machines, a lot of servers, networking equipment, storage equipment in there, and it got overheated and the server room burnt. So that was the local way of operating, which, like I said, some companies or some businesses are still using it currently. So, like I was saying, okay, then another example of this local setup is when you go to a printing firm where maybe you want to print a flyer or you want to print on the t-shirt and all of that. They have usually have those people in front that you bring your work to, you give it to them, and if she's working on it, she can tell you, okay, she's done. You can go to the other building or to the person at the other end to print it for you. So how come the person in front is sending you to that, and you get there and your work has actually been, pushed aside because there's somewhere in that building a room. Not all of some of them, they actually send it through, email or Google Drive or those multiple ways of sending it. But sometimes the well set up ones, like one I visited recently, they have a server room where they send the work, then it's, whoever is connected can access your work, So you go there and they print it. That same operation going in, that's the networking, going on there. The, that's local compute, local cloud. That's the kind of local cloud there. So I'm trying to give us different ideas of, these are the things that actually happen around us, just that we haven't taken note of it. Okay, so like I said, some of this cloud compute is like the banks. Most of the banks, they have data centers, but it is just for them. They are not sharing it, they are just using it for their own operations. MTN, Globalcom, although I heard that MTN now is also selling some of their, you know, um, computer as a service. They're also selling some of their, they sell some of their cloud services now. But most times here in Africa, most of the businesses set up their own cloud environment for themselves to avoid the high cost of um, this cloud service providers. Okay, so this remember, cloud the data centers, right, are owned by businesses or organizations. So the organization that owns a data center might not be using it for themselves. They now offer it. That's innovation as well. They now offer it for sale. computers as a service, because they know that there's a lot of businesses out there that do not have the capacity to provide the level of compute they need. They know some people do not have the ability or capacity to provide the level of storage, networking that they need. So now they get up, build, go to a site, build, put up the building, buy all the equipment, set it up, and now offer it as a service. Yes. So that's how you are able to do a lot of things now online. I will still be talking about examples of how we are using this in our day-to-day, lives. Okay, so like I said earlier, before now, this is your local environment. This is your house. You have your computer. You go and buy an email software. You go and buy an operating system software, and then you go and buy this server, which is so expensive. You might not even have enough money to buy it. But then, because of you want to be sending emails round, the world, you have to buy this. If you look here, you see email server. You have to buy an email server, buy the email software, buy the operating system software to run the email, and then this is your desktop at home. So you set this up locally. That was before. Although, like I said, some people are still doing that today, but this is no longer scalable. This is not really efficient anymore. Okay, so when we talk, what is actually inside this building, or different types of servers. So we have the email servers, we have the productivity software, you have the web servers, we have the databases, even YouTube. This YouTube now that we're using is in a data center, is hosted in a data center somewhere. YouTube is an application, right? YouTube is an application. So how are we able to just connect to YouTube and use it? Is because YouTube is hosted. It's not hosted in your house. You can just access it. Okay, let's use the basic one that we all use. WhatsApp. WhatsApp is an application hosted in different data centers. It's an application hosted somewhere. That's why you're able to put pictures, send pictures, do all those conversations. And then let's say your phone gets missing, you buy another phone. Once you download WhatsApp, provided you've been backing up your messages and photos and pictures, once you connect, within minutes, all your pictures, all your conversations, all your contacts, WhatsApp contacts will download again. And why am I saying that? I've had that experience, so everything comes back. So where we're there, like, ask yourself, well, that information, because it's not in the new phone, the old phone is missing. The old phone, let's say, even fell in water and spoiled. So you can't tell me, okay, it was in the old phone and it's now, no. It's being backed up somewhere. It's being backed up somewhere. That's things like Facebook. Facebook is also an application. It's an application. You put all your pictures there. Those pictures are not on your phone. Okay, let's say you went for a wedding. Let's say it's even your wedding. Give somebody a picture, or your birthday, or a celebration, graduation. You take pictures with your phone, and then you post it on Facebook, right? Or Instagram. And then that phone gets missing or gets broken. You can easily go back with a new phone, log into your account, and download those pictures you uploaded on Facebook and Instagram back into your phone. How is that happening? Because these applications are hosted in data centers somewhere in the world, not on your local device, which is your phone. Because if it's the ones that's actually in your phone, when your phone gets missing or gets broken, it's gone. You can't access them again, unless maybe you put it in the small micro SD, the storage device that you normally insert. So if you were able to bring it out and it's still okay, then you can insert it into the new phone. If not, the only way you can recover all those things is by either downloading them back from, if you've been backing them up, or you go to like Facebook that we're talking about. You go to Facebook and download those pictures back. That's the cloud. An application hosted in the cloud. Even those of us that use Apple, you hear iCloud. It's just a storage space in a data center somewhere. All these things are hosted in data center. Your Netflix that you watch, all those movies, they are not on your TV or your phone. They are hosted. They are they are video files hosted in a data center. So you are able to access and connect to them through the internet. That's why the networking devices have to be there. If you have a data center, you have your servers, you have your storage devices, and then you don't have the networking devices, you can't access them. Okay, so networking devices helps you to access them via the internet. So you can actually access it from anywhere in the world. That's why you are able to post something on Instagram from here in Nigeria and someone in Australia will say, "Oh, I see you people had your celebrated your birthday." How? How are they able to do that? Because it's hosted. Immediately you upload it into your Instagram app, it goes to a server somewhere in the world. And then because it's now on the internet, anybody anywhere in the world can access it. Okay, I think we now get a better picture of what cloud computing, how beautiful this innovation is. So with cloud computing, you can basically do so much more. All you need to do is, log into an application, get access to an application, download an application, and you are able to do a lot of things because the cloud providers have made it so easy. They have made it so easy for people to be able to do all these things. So we have the different types of we have the different cloud service providers. Let me try and get their names. So we have those data centers, like I explained, now are being hosted. It didn't just appear. Somebody or a company or a group of people somewhere decided to, okay, we see that there's need for this because it's a solution, provision. They provided a solution for the world. So they went to a place, a land, built a data center, equipped it, and these are some of the mega names, the popular ones. There are so many right now. If you go to Google, search data centers, you see a lot of them, that now provide this service for us to buy and use. Okay, so we have Amazon AWS, Amazon Web Services, AWS, one of the most popular ones. We have Microsoft Azure. Okay, so this is from Microsoft. So their cloud provider or their cloud is called Azure. So when you hear Azure, now you know that, okay, they're talking about cloud service provision by Microsoft. And then we have Google Cloud Platform. Most times you won't hear it called Cloud Platform. You might just hear Google Cloud, or you might hear GCP. Mostly around the techies, you hear GCP. So now you know that, oh, it's the same thing they're talking about. It's just that this is provided by Google, this is provided by Azure, and this is provided by Amazon. And then we have Alibaba, we have IBM. So this Alibaba is not is by AliExpress, but this is um, their cloud service is also called Alibaba. So these are the organizations that took it upon themselves and said, okay, we can provide this service. We have enough capital and enough, we can hire enough engineers and everything required to set up the cloud. So they offer this as a service now for us, so that now if you have an idea to produce an app, all you need to do is get an Amazon AWS account or any of these service provider accounts, log in, and start doing what you want to do. At the end of the day, you pay for what you used. You are not going to go to the market and start looking for a server. Okay. So why cloud? Why cloud? Why cloud computing? Okay. From what I've said so far, you already know that cost is one of the reasons why you would want to adopt this. Cost is one of the reasons why, because depending on the kind of service or even products or company you're setting up, If, let's say, for instance, like you want to you're producing, even the banks, what the bank is not the bank's core or primary focus to start thinking tech. Their focus is to provide banking services. So for that, they need to focus on things related to finances and banking, bank related services. But then, without the cloud, they are going to now start figuring out or buying server, setting up a data center to run that. you know they have to now start doing that, which will now cause them to deviate from what they are doing. One, now the money they would have used to focus on their core and primary service or product, they are going to now split that and start using some of it to do this. So cost, with setting up a data center, it is so cost intensive that if you start doing that, you might see that most of the money that you would have used to set up your business will be spent doing this. And this is required so that the world, your business can go global. Like Instagram now, you can pick up, let's say, this phone now and start selling it on Insta. Set up your shop in 5 minutes. You've set up a shop on Instagram and you're already selling a phone. I can even get the customer right now, you know, like that. Why? Because this is already provided for you. But imagine that, okay, you want to start selling things and there was no Instagram, Facebook, or any of those online applications where you can post and sell. You have to go and start buying computers. Definitely, most of what you can't even set up shop. That's just the simple truth. Now we can even order online because somebody has already taken the overhead off us. Okay, so cost is a primary concern, and that is why cloud computing came as a solution. Secondly, reliability. Why cloud computing? Reliability. Okay, let's say you have money and you were able to set up your servers, storage devices, networking devices, and all of that, and all of that, and your business, okay, is now online. Good. But all that equipment, all those devices are in a warehouse, or maybe in a store beside you, or warehouse beside you, and then it catches fire. Let's say it catches fire one day, or maybe weather, emergencies, or all those weather situations, hurricane, although we hardly have that here, but yeah, we're talking globally now, right? And then that place gets burnt, or you know goes down, or the building comes apart. Stuff like that happens. Okay, what happens to all that money you have spent? Gone. One. Two, another thing is, now nobody can access nobody can access your business because your site has gone down. Okay, but with cloud computing, these companies that I talked about, AWS, Azure, and GCP, they have multiple locations around the world. Multiple locations. You could Google that. Multiple locations, like a whole lot, hundreds of locations, not just in tens, hundreds of locations around the world where they have this same setup. It's like a copy of data centers, clusters around the world. So if primary site one goes down, there's another site. That's what we call redundancy. Redundancy is ability to, you know, go to another, have another option, multiple options. Okay. So this site goes down, they will just start directing the traffic to another site. If you have the situations where you went to a bank, right? And then they'll tell you, oh, network is down, network is down. Why? Some of them that use services that use local setup. If, like the one I experienced that I spoke about a few minutes ago, where I worked in an office where our server room burnt. We couldn't work for almost a week, you know. and they had to set everything up again from scratch. It was after that experience that the bank now started saying, you know what, no, no, we have to find another alternative, because we lost a lot of customers, because customers will come, we can't access their details. We have to start sending them to different other locations. And then fraud also happened, because some of the VIP customers that we attended to, or supposedly VIP customers that they had to call like other branches or locations to get their details. By the time you now probably process that transaction, they will now they might even go to another location and redo the transaction. They might even do a withdrawal again in another location. And then when you are now ready to actually now post the transaction, you see that the money is not even in the account again, right? So the bank incurred lots of losses because of that. So they started looking at this option, because they realized that no, no, we can't run with our servers and all our devices in it. Not that there's still no server room, there's still server rooms, that does some a few local operations, like when they do process something here, they can tell you go to the secretary to pick it up. They will send it to the printers, to the secretary's printer. So those ones are local operations within the branch there, right? Okay, so you get the drift, where the service provider, those providers, there's reliability. There's no, if it's an organization that uses them, you can't go there and they're telling you network is down. Even if it's down, it can just be down for a little bit and it's up again. In fact, AWS gives you assurance of 99.99999% reliability that they are going to be up. So you can imagine that level of um, reliability, where your system will be up all the time. So the possibility of even going down is like 0.0000000%. So that gives you assurance when you now focus on marketing your product, knowing that I'm always online. You can even put that as part of your sales pitch. My business is always online, right? Because you're using cloud, cloud service providers. Another thing is scalability. Scalability. An example of scalability that's very relatable is this. So scaling, ability to expand easily. Let's say you launch an app, okay, and you launch it on your local computer. If that app, let's say when it goes to the market, or PAM, you've launched it and 100 people connect, your computer can bear that. But imagine that the app is so good that it just goes viral in hours, and millions starts connecting. That your system will crash immediately, because you can't handle the level of compute going on. Even we had it in some financial institutions, which I've experienced, because I had an insider information. So the bank launched the app, and then once they launched it, everybody started, all the customers started connecting. And what happened, because they were using local setup, not like it was even local, it was their national data center, right? But they couldn't handle the compute required. They didn't couldn't handle the the traffic. They couldn't handle the traffic, because there were so many connections that the servers started shutting down. So, and they lost some customers because of that. Because once it has to do with finances, it's not a joke. Okay, so usually what companies do is that when they start up an app, they do what we call a test run with only a few. Even I know a particular bank that what they do is that when they set up when they about to launch an app, they do a test drive with the staffs alone. So only the bank staff will use it, talk about the experiences. That's where you are having all those testers. That's why testing now, as an IT technical skill, is also a good job, because you test apps for people, or for companies, or even for individuals. Okay, so they first of all test it within the organization for some time, see how it's handling the traffic, the throttle, all of that. The bandwidth, is it enough? Will it crash if millions connect to it at once, and all of that? And then when they see how good it is before they now start making it this thing. But with cloud computing, you don't need to think of all of that. Why? Because the service provider, you already saw the building I showed you. The compute is so massive that even if millions connect once, all that needs to be happen is that the servers just, it can move from one server to the second server to the next server to the if you, let's say your app or whatever it is you launch now took all the servers in the whole data center, let's even assume that, which is hardly possible. There's another data center that can take that load off you. And the typical example is like now, if you have an event business, let me bring it down to the basic level, an event hosting business, and then you have 5 workers. Let's say you have 5 workers during the off peak periods, which is around this time. During December, you can't have if, especially if your system business is booming, you can't use 5 workers during the festive periods. Why? Because then events are supposed to be, there's going to be so many events that 5 can't handle it. So you have to scale. How fast can you scale? How fast can you scale? Can you scale so fast that you are ready to, I've had experience where there was an online shop. I wanted to order something. They launched something, was so nice, and a lot of people, the woman did an advert, and we were like boom, boom, boom. A lot of people came, and a lot of us were refunded our money. Why? Because she couldn't scale. She couldn't scale the products. So now I'm talking of scalability when it comes to products. The product she had wasn't enough. Okay, so that's scalability. With cloud, the cloud can scale fast, because you don't even need to worry about that. Your own is just okay. Just keep doing your thing, focus on your business, and the scaling is happening all by itself. You know, automated scaling. Okay, so we have benefits of cloud computing. I don't know if I want to talk about that today because of time. Okay, but let's just talk about a few of it. Another one is, let me see if it's here. Benefits of cloud computing. Okay, trading upfront expense for variable expense. So this I've highlighted a lot as I spoke. Trading, to break it down, upfront is the money, that expense you do even before the business takes off, before the business starts. That upfront cost, the capital, the assets expense. So imagine if you're setting up your cloud environment in um, in your local, doing a local setup. Most of the money you're going to actually now use for the business will be spent buying servers and other resources, hiring staff that will even manage. It's not easy to pay an engineer that will set this so up, and you're not going to hire one engineer because the cloud engineer is going to be there. Then the network person too, whose job is completely different from what the cloud engineer will do for you. You're going to pay all of that. Now, you've not even started talking about the business, the core thing you want to do. Meanwhile, your money has been spent doing that. So you are trading. So to trade now is you are exchanging upfront expense for variable. So variable here is you are paying as much as you are going to use. You're not going to pay any major expense. You pay as you go. Exactly, that's the word I'm looking for. Pay as you go. You only pay for the compute resources you consume instead of investing heavily in data centers and servers before you know how you are even going to use them. Because you might even set up all those things and the business might not even work, you know. But if you are using cloud, you launch the app or you start the business, it's not working. Maybe you only started small, you're able to start small and you're online, and it's not working. You can easily change because you've not spent so much. But if you set up a whole, spend all of that just to set up um servers and all of that, hire staff. You see, so you're trading upfront expense, you're exchanging upfront. That money would have spent doing all of that for variable expense. Why is it variable? Because this month your cost for the cloud, like the example I used as an event planner. As an event planner, the demand around this period is not so high compared to festive period. Festive period, the demand is so high. So let's say, oh fine, let's do booking. If you have a booking app, if you have an app that books maybe vacations or flights around this summer period, the app is very active because why? A lot of people on holiday, they are looking for where they go for summer halls and all of that. It's going to be active. So your app is going to be receiving a lot of throttle, a lot of traffic, and you can scale, right? You can, like this, you know that this festive period, your cloud cost is going to be a bit high, but then so is your business because you're also getting a lot of business within that period that you're using that high, cost of cloud services. And then after this period, school resumes, and then the demand goes down. So by September, October, November, you see that your cost will go down too, matching what is happening in your business. So you see, it's variable. There's no fixed cost. There's no fixed cost because now you're not paying the engineers, you're not paying, because if we are going to set that up locally, it's going to be fixed cost. You're going to pay the engineers their salary, you're going to, so, but now it's variable because it's what you use that they are going to charge you for. They won't, the cloud, those service providers will not charge you for what you didn't use. Okay. Okay, so that's one of the advantages. Then you stop spending money to run and maintain data centers because in data center often requires you spend more money and time managing infrastructure. So when we talk infrastructure, we are talking of all those servers, devices, wires, connections, cables. Yes. So you focus on your tasks, focus on more on your applications and your customers instead of the back end. So the back end is taken off of you. So you don't spend your money there. Okay. Then you are not guessing capacity. You don't need to predict. Your prediction is minimized, reducing headache for you. Your own is once the connection is there, automatically scaling is going on. Okay. And then there's elasticity. Let me see if it's here. Okay. So elasticity, I think it has to do with agility. Elasticity, ability to shrink, ability to expand. Elasticity, elastic, when you drag it and then it pulls back. Like the events planning thing or a booking app. During this period, it stretches. Why? Because there's more people. There's flexibility, there's more people. And then by September, October, the app comes back. You can do that with cloud. So maybe you are using this particular amount of the service provider services, and then by next month, September, when school starts, your app is no longer getting so much traffic because people have gone back to school and to work. What happens? The services you're using is going to be less because your app is no longer getting so much traffic during that period because it's not a festive period. Okay, so um, that's elasticity and agility, agile, being able to be agile, to adapt, stretch, come back, stretch, expand and contract. That's a benefit of cloud computing. So I think for this particular recording, I'll stop here. If you watch this, it will be good if you watch this before the class. That way you have your questions because the class primarily will go through a little bit of this again, and then we have a question and answer session. So come with your questions and then we'll tackle it during the class. Thank you so much for listening and watching, and see you next time. Bye.